How to make metric conversion factors that relate to the base unit. First, it might be helpful if you have a table nearby that you've created that shows your metric prefixes and their values. Maybe you can use one that you've taken down from notes in class or from one of my PowerPoint presentations or a textbook. Eventually, you wish to be familiar enough with these prefixes so that you understand what each one stands for, what order of magnitude or power of 10 the prefix relates to. To make conversion factors, remember that any two quantities that equal each other can be used to make a conversion factor. Any two quantities equal to each other can form a conversion factor. For example, the metric prefix kilo means 1,000, which is the same thing as 10 to the third power. So you might wonder, how many grams equal 1 kilogram? Let's look at some conversion factors. It's always helpful to ask yourself which is larger and which is smaller. Are grams smaller than kilograms? Or would grams be larger than kilograms? Well, of course, looking back at our prefixes, since the gram would be our standard unit and kilo is a larger prefix, it represents a higher and higher power, then there would be many grams in a kilogram. There would be lots of these smaller grams in a kilogram. How many? 1,000, because kilo means 1,000. So we could write that there are 1,000 grams in a kilogram, or 1,000 grams equals 1 kilogram. Notice that we're using the base unit here. Since kilo means 1,000, we write 1,000 of the base unit in one of those kilograms. Any two things that equal each other can be used to make a conversion factor. It is also true that you could have written 10 to the third power grams equals 1 kilogram. So now take what's on one side of the equal sign, put it in the numerator. Take what's on the other side of the equal sign, put it in the denominator, and we can write a conversion factor for dimensional analysis. So we could say that there are 1,000 grams in 1 kilogram. And any conversion factor can also be flipped upside down to give a second conversion factor. It's true as well that there is 1 kilogram per every 1,000 grams. You might have chosen to write it like this: 10 to the third grams for every 1 kilogram, or 1 kilogram for every 10 to the third grams. All of these are valid conversion factors for use in dimensional analysis. There's yet another way that you might have expressed this equality. Since 1 gram is equal to 1/1000th of a kilogram, then you might have even written this conversion factor as 1 gram equals 0.001 kg. And you could have made a conversion factor out of these two things. This is a true equality. The most important thing is to be certain that the two items you set equal to each other really are truly equal. That 1 gram really is 1,000th times the size of 1 kilogram. Let's take one more quick example. How many micrograms equal 1 gram? This time we'll look at a smaller unit of measure. Well, ask yourself, what does the prefix micro stand for? Micro means 1/1,000,000th, or 10 to the minus 6 power. All right, how would I write this now as an equality? Well, there's several different ways that I might choose to write it. I could say that there are 10 to the minus 6 grams in 1 microgram, meaning that 1/1,000,000th of a gram is the same as 1 microgram. Notice that I'm using the base unit again next to my power of 10 that the prefix stands for. You might have also chosen to write this in standard form. 1/1,000,000th would be 0.000001 of a gram. So there are 1/1,000,000th of a gram in 1 microgram. Micrograms are very, very small. So we could easily make conversion factors here. We could say that there are 10 to the minus 6 grams in 1 microgram. We could flip it upside down if necessary and say that there's 1 microgram for every 10 to the minus 6 grams. We could use our second conversion factor example here and say 0.000001 grams in 1 microgram. And of course we could flip this conversion factor upside down as well. And yet there's even another way that you might think of this. Since micrograms are very small, there would be 1,000,000 of them in 1 gram. You might also choose to write the equality like so. In a gram, there are 1,000,000 micrograms. Or 1 gram for every 10 to the 6 micrograms. And so we could use these equalities to make conversion factors for dimensional analysis as well. Practice certainly helps in making conversion factors, and so the more you use dimensional analysis, the easier this will become for you.